This section is on permutations and combinations. We're going to look into how to tell the difference between when a problem is permutation versus a combination and the different formulas to use for each. A permutation is a group of objects where the ordering of the objects within the group makes a difference. So in short, for permutation, we're just going to say order matters. Okay, and a combination is when the order is irrelevant. So we're going to say order, again in short, does not matter. So I did this example in the last section where 5 candidates are running for 3 positions. The top 3 vote getters are chosen president, vice president, secretary in that order. This would definitely be a permutation because if you're in first place, then you would be put in president, but if you're in second place, you would be put in vice president. If we wanted a combination, we could say, okay, well, the top 3 vote getters are put on, instead of like president, vice president, secretary, maybe just a council where everyone has equal power. That would be where we have combinations of people. But in this case, it's a permutation. So, and we worked with the slots or the boxes in that last video where we said, okay, well, at first we have 5 people times 4 and then times 3 to make 60 different possible ways to order those 5 candidates in those 3 positions. So to reiterate that, yes, a permutation is when order does matter. In your calculator, it will look something like this. It'll say NPR. So that's like saying N choose R using a permutation. So N represents the number of options available. So in that example, it was 5. And then R is the selection spaces. There are only 3 selection spaces for office. So we'd say 5 choose 3. So that's 5 factorial divided by 5 minus 3 factorial. So that's 5 times 4 times 3 times 2 times 1 divided by 5 minus 3 is 2, so then that's just 2 times 1. And then I'm just canceling out at that point, so that's 2's and then the 1's. So that's where we end up getting that 5 times 4 times 3 to make 60 from. And by the way, sometimes this isn't quite as easily done by hand, so if you're using this function in the calculator, I think you'll look in the math screen and go over to the PRB menu for probability, and you'll choose this. You'll have to type in, for example, 5, then go into the menu and choose that option, and then type in 3 afterwards. That's the order of which you need to type it in on the calculator to be able to do it. So another example here, this is kind of continuing from the last section where we were using that multiplication rule. So let's say we want a true double ice cream in a bowl, so we want 2 different scoops. How many choices do you have if there are 31 flavors? Well, the first time you choose a flavor, there are 31 available. And if you don't want to repeat, then you would say, okay, well, after that first choice, I have 30 now to choose from for the second flavor. So then we get 31 times 30 to make 930. We could also plug these numbers in the formula as well. So remember the formula for a permutation. This is where order matters is n, oops. That's where n factorial divided by n minus r factorial. So in this case it would be, we have 31 flavors to choose from. We'll say 31 minus 2 factorial, so that would just be 31 factorial divided by 29 factorial, and you'll still get 930. And note again, this is if the order were to really matter. Now, unless you're a really picky person about how you like your ice cream scoops, order in this type of problem typically doesn't matter. So If it doesn't matter, what happens is we're going to end up double counting a lot of those possibilities. To illustrate that, if we're doing a permutation, if you're really picky and you want the order of the ice cream to be very specific, you could say, okay, well, I think chocolate and then vanilla is different than vanilla and then chocolate. But if you're just concerned about the combination of two different ice creams, these things are this pair of chocolate and vanilla can actually be the same thing. Now the good news here is we can easily just take that 930 and instead of double counting everything, we'll just single count. So to do that, we would have to just divide everything by 2 to make 465 instead. Now dividing by 2 is not always the trick, it just worked out in this case. It really has to do with the amount of spots that are available, and we're going to add a factorial onto that number, and that's going to show up in our next formula coming up, the formula for combinations. So the formula for a combination is n factorial divided by n minus r factorial times r factorial. Notice all of that on the bottom. So in that last example, it would be 31 flavors, so number of options, and then we have 31 minus 2, our selection size, factorial, times, and again, this is where it's a little different. We have to avoid double counting or repeating options since we're only concerned with grouping items and not ordering them a certain way. So in that last slide I said dividing by 2. Well, it's not just a trick of dividing by 2, it's really of that extra dividing by 2 factorial, because there were r is equal to 2, and 2 factorial is 2 times 1, which just happens to be 2 in this case. Oops. So we'll say 2 factorial. So that's going to end up being 31 factorial divided by 29 factorial times 2 factorial, which we will still get 465 in the end. And if you're going to do this in the calculator, you don't really need to type all this out actually. You can just go to the math screen. First you will have to type in the number for n. So in this case you would type in 31, and then you would hit the math button and then go to PRB, so scroll over to that menu, and then you would scroll down to the NCR option, hit enter, and then you would type in the R value, which in this case is 2. So after you do that, on your home screen on the calculator, it will look like this. It will say 31 NCR 2, and when you press enter, you should end up getting 465. So this time, what if we wanted a true triple instead of a true double? And let's assume that we're not looking for order here, we just want to know how many combinations of triples we can have. So again, there are 31 flavors to choose from, so n equals 31, but this time r is going to be 3. So our formula would look like this. We'd say 31, choose R, and that the C also stands for combination, 3, is 31 factorial divided by 31 minus 3 factorial. And this is what I mean by the trick is not just dividing by 2, it's dividing by that R number factorial. Okay, so we wouldn't just divide by an extra 3 here, we'd actually include the 3 factorial. Okay, so in the end it would be 31 factorial divided by 28 factorial times 3 factorial, and of course all that on the bottom is done before you divide the top by the bottom. So if we were to do that by hand, that would look kind of like this. We'd say 31 factorial is just 31 times 30 times 29 times 28 times 27 times 26 times all the way down to 2 times 1. Okay? All of that divided by 28 factorial would be 28 times 27 times 26. So similarly, all the way down to 2 times 1. And then also we're multiplying by 3 factorial, so 3 times 2 times 1. So notice what can be canceled out here. We have 28, 28, 27, and everything in between, all the way down to 2 times 1, 2 times 1. So in the end, we'll be getting 31 times 30 times 29 divided by 3 times 2 times 1. So we'll get 26,970 divided by 3 times 2 times 1 is 6. So we'll get 4,495 different combinations. And of course, you can always type this in your calculator. We can just go in and say, here, we'll do this on the side here. So we'll just say 31 in CR3. You should get the exact same thing. Okay, so this is one that if the order weren't to matter, we would say that there are 4,495 combinations of triples from those 31 ice cream flavors. So here we have some quicker examples. So this one says 8P3. Really this means if I have 8 options, or for example 8 people running for 3 positions in office, and the order actually matters, how many different possibilities are there. So how many different permutations, that's what the P stands for, are there. So if we're doing the formula, it would be 8 factorial divided by 8 minus 3 factorial. So you'd be getting 8 times 7 times 6, 5, 4, 3, 2 times 1. 8 minus 3, 5, so then it's 5 times 4 times 3 times 2 times 1. We'll just cancel stuff out. And we were doing examples like this earlier where we just had the slots. So 8, and then after that first person, there were 7 people left to choose from, and then the third slot, there were 6 people to choose from. Very similar outcome here. So we would just say 8 times 7 times 6, and let me put that in the calculator real quick. So 8 times 7 times 6, so 336 at the end. Now you don't have to always do this by hand. You can just type this in the calculator as well. So I'm going to erase all this and show you again the commands that you would use to do this in the calculator. So we should be getting 336 in the end here. Alright, so this time we'll just say 8, and remember to do that in a calculator you got to type in 8 first, so let's write that up here. N equals 8, R equals 3. So it's 8, then you choose math, PRB, and then you choose N. This is a permutation, so NPR. Hit enter. And then you type in 3 after that. So on your home screen it'll look like N, or 8, NPR 3. And you should get the exact same thing that we got when we did it by hand. Next, there is a combination problem. So it says solve 5, choose 3 using combinations. So how many different ways can I order 5 options into 3 slots? So in this one, the formula would look more like this. We'd have 5 factorial divided by 5 minus 3 factorial, and then times 3 factorial, because I don't want to say double count here, but in this case almost kind of like triple count. We don't want stuff to repeat, so that's why that extra 3 factorial is in there. And we can do that by hand, or you can just go into the calculator, because we've already done one of those by hand. Go into the calculator and just type in 5 and do the same order of things that I did above in the previous problem, except this time you're choosing NCR, so it would look like this: 5NCR3. And you should be getting 60. Word problem example here. So 43 drivers start a race. How many top 10 finishes are possible? Now, in a race, typically order matters. We could say how many groups of top 10 finishers are possible, but it just says how many top 10 finishes are possible. So we're going to assume that this order does matter, because coming in first is a lot different than coming in 9th or 10th. So there are, we'll say N equals 43 and R is 10. Now if the order matters, it's a permutation, so I would say 43, choose 10, and notice I'm using P and not C. Right, if you type that in correctly in your calculator, you're going to get a really, really big number. It'll look like something like 6.95 95762 e to the 15. You can write this in scientific notation. This just, if we were to estimate, we could say, oh, that's about 6.96 if we're rounding, times 10 to the 15 possibilities. So a bunch of different ways we could have top 10 finishers. Last example of this section, to compete against another school in a math competition, we need to form a 5-member team from a class of 11 students. How many different teams can be formed? So in this problem, it's important to note that there's no best person and worst person on the team. We just have a team of 5 people. So the order doesn't matter, therefore it's a combination. So we're just going to say that here N equals, we have 11 students that we could put on the team, but only 5 could make the team. So we'll say 11, choose 5, and of course in the calculator we'll type out 11. We'll use that NCR option, and then 5, and that will come out to 462 different ways that we could put a team of 5 together from 11 students.